All right, y'all, we're looking right now at the topic 2-6 section of notes. It says solving systems of inequalities by graphing. And so, what I'm going to do is you can look at all of the steps right here, but what I really want to do is I'm just going to talk through them as we work on these problems. Okay, so let's start on number one. The first step we need to do is to solve each inequality for y. That is, we need to get y by itself. And as you look at problem number one, look at that. We've already got y completely by itself in both of our inequalities. Okay? So we move on to step number two, graphing the lines. Okay, what we're going to do is since we have y by itself, that means the other side of this inequality is in some kind of mx plus b format. Okay? That is something that we can graph on the graph as a line. So that's exactly what we're going to do. Okay, we're going to start with the y-intercept. Okay, on our first line, I'm going to graph this one in red. So I'm going to take that y-intercept and I'll go up 3. That's our first point. And then we're going to use the slope of 2/3 to find the rest of the points. Okay, so that means I'm going up 2 and over 3, up 2 and over 3 to get to all the rest of these points. Okay, when we graph this line, the thing that we need to watch for is whether or not which one is it going to be? Is it going to be a solid line or a dotted line, a dashed line? Okay. The way you can tell if you're supposed to fill in the entire graph line or just make it a dotted line is by looking at the inequality symbol. Okay. So it's going to be a solid line if you also have equal to as part of the inequality. If it's just less than or just greater than, it's going to be a dotted line. Well, we look at our one that we're graphing right now in red, and it's also equal to, that is less than or equal to. And so that means we're going to graph this as a solid line that goes across. Okay, we're going to do exactly the same thing with this other one. Okay, with our other inequality, we're going to treat it like a line, just like we did that other one. We're going to start at our y-intercept, which is -2. And we're going to look at our slope. Okay, remember when there's not a coefficient written down that it's -1. So that means to find our other points, I'm going to go down 1 and over 1 because our slope is -1, down 1 over 1, down 1 over 1, all the way across this whole entire graph. Okay. We look at our symbol again. We look at our symbol and we see that it has an equal sign as part of it. So this is going to be a solid line. In fact, both of these were solid lines. A lot of times you'll have one or the other. Sometimes you'll have both of them solid, both of them dashed. They're all these problems are a little bit different. So we graph our other line and boom, we've got our two boundary lines. Move on over to step number 3 now. Step number 3 says to shade on the appropriate side. Okay, we're going to shade above the line if it's greater than. We're going to shade below the line if our symbol is less than. Okay, so we look at both of these. Okay, our top one in red, that is a less than symbol, so we'll shade below. And the bottom one in blue is also a less than symbol. So we will also shade it below the line. Okay, here's what I mean by shade above and shade below. We're literally going to look at this line. Okay, I'm going to shade all of this area that's down below the red line. I'm going to shade it in red. Okay, every part of the graph that was below the red line gets shaded in red. Every part of the graph that's below the blue line is going to get shaded in blue. Let's talk about why we're shading this. Okay? The reason that we're shading this is because the inequalities work a little bit different than equations. Okay? A lot of time when we solve an equation, you end up with x equals one single number. Okay? And it's that one number, like x equals 1. That is all. 1 is the only answer. Well, if you end up with an inequality, like x is greater than 1, there's a whole bunch of numbers that all fit into that category. Okay, in fact, there's an infinite number of things that fit into the qualification of x greater than 1. The same thing happens when you're dealing with a system of inequalities. Okay, whenever we solved a system of equations in our previous lessons, we had one specific x and one specific y that fit. Well, this time there's a whole bunch of x's and y's that fit because it's not an equation, it's an inequality. And so what we've just done, all of this area that got shaded red, all of this business right here that got shaded red, was all of the x and y values that fit into the top inequality. All of this area that got shaded blue is all of the x and y values. All of these points have coordinates, x and y coordinates that fit into the bottom inequality. And so all of this area that got shaded both red and blue, that is the area, these are the x and y values that fit into both inequalities. Okay, so if you wanted to make a little note right here, this part that got shaded with both colors, these are what represents your solutions. Okay, all this part that got shaded with both colors, that is what represents the solutions to the system. Okay, let's move on now to number 2. Problem number 2 on the back. You can see right off the bat right here that both of the y's are already by themselves, so we don't have to do anything else. And now we're going to look at this symbol, okay? That is a greater than symbol, and it is strictly greater than. It's not equal to. So that tells me when we graph this line, when we graph this boundary line, it's going to be a dotted line, and since it's greater than, we're going to shade above. I'm going to look at the same qualifications for this one. This symbol is a strictly less than. It's not equal to, so it's going to be another dotted line. And we're going to shade it below. Okay, so let's put that on the graph. Our blue one, our y-intercept is +2, and our slope is 2/3. So I'm going to start at my y-intercept. I'm going up 2 and over 3. Okay, slope of 2/3 means I'm going up 2 and over 3 to get my other points. This time it's going to be a dotted line. It is not a solid line that connects. So you can see that I've just kind of broken it up as I go down the line right there. Okay, on that one, we're going to shade above the line. These are all the x and y values that fit into our top inequality, the first one in our system. Our other inequality, the line starts at -1. Our y-intercept is -1. And we've got a slope of 2/3, so I'm going up 2 and over 3, just like I did on the previous one. Up 2 and over 3, or down 2 and to the left 3. This is another dotted line. So you can see I'm just kind of breaking it up as I go down here. And this time we are shading down below. Okay, so all of this area that we shaded in blue, that's the points, the x and y coordinates that fit into the top inequality. All of this part that's shaded in red down here, these are the x and y values that fit into the bottom inequality. And we ask ourselves, is there any part of this graph that has overlap? Is there any part that got shaded with both colors? And the answer is no. In fact, these two sections are completely separate from each other. And what that tells us is that there is no solution to this system of equations. There is no solution. If there's no overlap, then there is no solution to the system. Go on now to number 3. We're going to do number 3 right here and call it a day. Okay? You can see the problem immediately right off the bat on number 3 is that this top inequality does not already have y by itself. So we need to make that happen. Okay, I'm going to rewrite it so we've got room to work. X minus 2y is less than 6. Okay, if we're working with that inequality right there, we need to get rid of whatever is not directly attached to y first. So what I'm going to do is subtract x on both sides. Now we ask ourselves, on the right side of that inequality sign, can we put 6 and negative x together? And the answer is no, we absolutely cannot, because they're not like terms. We have to have negative x and positive 6 separate from each other. Now what we're going to do is we're going to divide to get that y by itself. We're going to divide by negative 2. And what that does is on the left side, it cancels out the negative 2, which is what we were going for. It gets the y by itself. But since we divided by a negative number, you have to also remember to turn that less than sign around and make it a greater than sign. Okay, we divided by a negative, so we have to flip that around. Okay, on the left, we've got negative x over negative 2. I'm going to turn that into positive 1/2 x. And we've got plus 6 over negative 2. That makes it minus 3 right there. Okay, so now I'm working with this one. I'm working with this inequality. We've got y by itself. This is going to be a dotted line, and we are going to shade above it. Okay, 1/2 x minus 3. We started our y-intercept. I'm going up 1 and over 2 to get those points, or down 1 and to the left 2. This is a dotted line going across. And we are going to shade all this part up above. On our other one, I'm going to do this one in red, and we're looking at that symbol right there. That tells us it's going to be a solid line, and we are going to shade down below it. So let's put it on the graph. We've got a y-intercept of positive 5 right up here, and a slope of negative 3 over 2. So that means I'm going down 3 and over 2. Down 3 and over 2 to get all the rest of these points. This is a solid line connecting it all. Solid line, and we will shade below it. All right, so there's some parts of your graph that only got shaded in red. There's some parts that only got shaded in blue. And there's a big chunk right here that got shaded by both. Those pieces right there, those x and y values, those are the solutions. Okay? If you're doing your homework, you don't have to necessarily do it with two different colors like this, as long as I can tell where the solutions are. Okay, that's what I'm looking for when you do a problem like this on your homework, is I'm looking to see, do you know what part was shaded from both inequalities? Okay, what part represents your solutions? All right, that's what I'm concerned about. So that's all we're going to do for the notes today. We'll have some more in our next lesson that's very similar to this. So we'll move on then. All right, y'all have a good one.